Hey, welcome back, and in this video we're continuing on our deep dive into WebAssembly, and in particular in this video we are going to look at branching and looping within WebAssembly, and then we will hand code our own Fibonacci function in WebAssembly, which will tell us whatever the Fibonacci number is for any number in the sequence. Okay, to get started, not everybody will be aware of what a Fibonacci number is, or even if they do know what it is, you might have forgotten. So Fibonacci sequences are quite special, and essentially how it's made up is the Fibonacci of n is equal to the sum of the two previous Fibonacci numbers. So if we look at that, and I've got a bit of a formal definition there, you know, fib of n is equal to fib of n minus 1 plus fib of n minus 2. And if I give a more sort of specialized example, the Fibonacci of fourth, i.e. the fourth number in the Fibonacci sequence, is the sum of the third number in the Fibonacci sequence plus the Fibonacci of the second number in the Fibonacci sequence. Okay, so that's a lot of me saying the word Fibonacci lots, but let's get a little bit more practical in that. So let's look at this really kind of big sequence here, but you can kind of see that the Fibonacci of 0 is 0, the Fibonacci of 1 is 1. Okay, that's making sense. But then if we go to the Fibonacci of 2, well, Fibonacci of 1 plus the Fibonacci of 0, which essentially is the same as 1 plus 0, because the fib of 1 is 1 and the fib of 0 is 0, and therefore the fib of 2 would be 1. So we're following that so far, and then if I go on to the Fibonacci sequence of 3, then that's going to be the Fibonacci of 2 plus the Fibonacci of 1. So if we think about it, the Fibonacci of 2 we just defined as 1, so that's going to be 1, and we defined the Fibonacci of 1 is equal to 1, so therefore that's going to be 1 plus 1, which is equal to 2, and then we keep just going on as well. So if I look for Fibonacci of 4, then that's going to be Fibonacci of 3 plus Fibonacci of 2, which would mean that if we look at the previous sequence, fib of 3 is 2, so that's 2, and fib of 2 was 1, so 2 plus 1 is equal to 3. And then we keep going, so we end up with 3, 5, 8, and if we look at the sequence, you can kind of see a standardized sequence, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and again, if I pick any one of those numbers, so if I pick 55 there, you can see it's the 34 plus the 21 is equal to 55, and I could do the same with the 89, 55 plus the 34 would equal 89. So that's how Fibonacci sequences work. And what we're now going to do is, before we go and hand create that in WebAssembly, it's a bit of a jump, right? Let's go to WebAssembly Text format and create it straight away. What we'll do is create it in JavaScript first, get an idea of what that sequence would look like, and then we will translate that into WebAssembly manual and see how that equivalent code would look in WebAssembly. Alrighty, so the first thing I'm going to do is create ourselves a little Node.js app for a second. Again, I could do this in browser with JavaScript, but for laziness sake, I'm just going to do it in Node.js. So I will just create a new folder, and we'll call that Fibonacci WASM, and we will just go into that. Cool, so we've got an empty directory at the moment, all cool. And then I'm just going to create myself a new Node.js project, so we'll do an npm init. And we'll just hit return lots, and that will have created our Node.js project. Nice and easy so far. Now, in my hastiness, I actually could have got Node.js to create my unit test frameworks there, but I was just going return. But we'll do that manually in a second. All right, so we've created that, and what we're going to do now is launch VS Code. So I can do that by just typing in code dot, and then that will open up Visual Studio Code in our machine there. So, okay, now that we've opened up Visual Studio Code, first thing we're going to do is we'll create ourselves a module, and we will create our Fibonacci function that we're going to export out. So let's call it Fibonacci.js, and I think we'll just do a module.exports equals function. So I'm going to use the old CommonJS method just now, just to make it easier for using with Jest, but you know, off we go. And before we create our Fibonacci function, what I'm just going to do for just now is just return 0. And then we'll fill out that function as we go along. So I've got my Fibonacci function, so that is good. And now what I want to do is create my tests. So I am going to call this Fibonacci.test.js. Okay, and that's nice and simple. And because Jest at the moment it's in beta, the ES6 module format, rather than using imports, I'm going to use common.js as I said. So we will just do Fibonacci equals require, and it will be .Fibonacci.js. Okay, so we have now imported our module there. So we'll create our first test, which just makes sure that for the Fibonacci of 0, we get 0 back. So we will do a test, and we'll type in Fibonacci of 0, and we'll just do that, and we will expect our Fibonacci dot Fibonacci. Yeah, I will expect our Fibonacci of 0, and we expect that to be a 0. Okay, so now that we've got our test, I can just save that, and we'll go into our package.json. We'll change our test to be Jest. And then we can go to our terminal and just type in npm run test, and we'll get an error because Jest command is not installed. So I need to do an npm install --save dev, and then we'll just do Jest. That will take a second. It will install in Jest, put it in our package.json, and then we can run our test again. So let's run npm run test again, run Jest, and our test passed. So we are looking pretty good at the moment because the Fibonacci of 0 is 0. So what I want to do now is start expanding out these tests, and we will just put in the Fibonacci sequences that we know. So we'll just put a few of these in. So let's do 1, let's do 2, 3, 4, 5, 6, and then we'll put a couple of other ones in there just for randomness sake. So we'll put 17 and 37. And no, I have no idea what they are just now, so maybe we'll comment them out and we'll fill them in a bit later on. So Fibonacci of 6, we would, let's just work the sequence, and then we're going to know better. So we know 0 is 0, so therefore Fibonacci of 1 is going to be 1. 0 plus 1 is going to be 1, so the Fibonacci of 2 is going to be 1. The Fibonacci of 3 is going to be 2 plus 1, so we would expect that to be 2. Then the Fibonacci of 4 will be the 2 plus the 1, so that will be 3. And then 3 plus 2 is going to be 5. And then 5 plus 3 is going to be 8. And actually, if I cheat for a second, I kind of know what the Fibonacci of 17 is going to be. It's going to be 1, 5, 9, 7. And I'm going to cheat again, and I know that the Fibonacci of 37, and the only reason I know it is I've just written it down in front of me in big letters so that I can type it out, is going to be 2, 4, 1, 5, 7, 8, 1, 7. So I just need to update these slightly. So let's put 37 in here, 17, and then 6, 5, 4, 3, 2, 1. And if I save that and then we run this again, and I get 8 tests failing and 1 passed because I've essentially I'm returning 0 in my sequence. Okay, so I have now built this, and that's nice. So now what I need to do is create my Fibonacci sequence in JavaScript. And then what we will do is convert that into WebAssembly. Now, there is multiple ways of writing Fibonacci's, and a lot of people would use a recursive function because it's easier to do. But because I'm going to try and demonstrate what branching and looping looks like, I'm going to avoid recursion, and I'm going to do a more iterative process, okay? First thing I'm going to do is I need a number to return, so I want to keep track of my Fibonacci number, so I'm going to have let fib n equals 0. And then because I want to track my n-1 and my n-2, I'm just going to set that to some initial values, but I'm going to have those variables so I can keep track of them as we go along. So I'll do let fib n1, and we're going to initially set that to 1, and we will let fib, let's change that, let fib n equals 2, and we're going to set that to 0. So n1 is representative of n-1, and n2 is representative of n-2. And then finally, I want to keep track of my index. Okay. So what I need to do now, I could implement this in multiple ways. I could use for loops, etc. But because I want to have a more direct translation when I do WebAssembly, I'm going to write this as a while loop. So I will do while n is greater than 0, and then we'll just open up our braces there. And that basically means that as long as I've got a, as long as my sequence is a positive number, then keep looping through the while loop. And the reason I'm doing that is that we're gonna loop back either way. So what we're gonna do is start from the number of the sequence, and then we have to walk back the way. So we'll be, rather than doing a kind of n++ in our while loop, we'll be doing an n-. So we're gonna start from our sequence, whatever our first number in the sequence is, and we're gonna work our way backwards. So to do that, the fib of n2 is got to be equal to the fib of n1, and then the fib of n1 is going to be equal to fib of n. So what I'm essentially doing there is each time I am going through the loop of the sequence, right? So I hit the next sequence in my loop. So every time I loop around, what I want to do is essentially set my Fibonacci, my n-1, to what the value was of Fibonacci on the previous loop, and then my Fibonacci of n-2 should be my Fibonacci of fib n-1 from the previous loop. So that way I'm always sort of tracking the n-1 and n-2 as I'm going through the loop, okay? And then to calculate my Fibonacci, I just need to grab the fib n1, so my fib n-1 plus my Fibonacci of n-2, and then, as I said, I'm going to decrement my loop, so I'm going to use the n-, so I can keep going around, and then obviously I will eventually get down to 0, and I can just return Fibonacci of n. So if I save that, so now that I've created my function, I can just run my tests and see if they work. So I will just clear my terminal, and then we'll just do npm run test, and it works, right? So you can kind of see our function is working. Fibonacci of 0 is 0, Fibonacci of 1, 3, 4, 5, 6, Fibonacci of 17, that works, and 37 as well. So those very large numbers I put in work. So I have a working algorithm in JavaScript. Now what I'm going to do is do the exact same thing, but this time I'm going to create it in WebAssembly, and then that'll give us an idea of how looping and branching works in WebAssembly land. Alrighty, so before I start hand coding my WebAssembly, what I'm going to do is actually create my unit test file for my WebAssembly again in Jest. Now, if you want to deep dive into how to unit test with WebAssembly, there is a video that I've already done, which is essentially called Unit Testing with WASM. And again, the link to that will appear in the top right hand corner there. But you'll probably get an idea of how this works from the way that I create this. So the first thing I'm going to do is create a file, and I'm going to call this Fibonacci .wat.test.js, and that is where I'm going to store my tests. Now, what I will do in this case, for the sake of laziness, is I am just going to copy all of my tests that I created for my JavaScript version of my tests. And then this time what I'm going to do is make this work with WebAssembly. So to do that, I'm going to create a Fibonacci module. We'll see that a little bit later, but just to show that kind of working, I'm just going to add in Fibonacci dot here so that we can easily execute our function that we're going to create in WebAssembly. So that's the only sort of thing that I'm going to do there. And then what I will need to do is, I have deep dives in my other videos, but what we're going to have to do is load the WebAssembly module that we're about to create. So to do that, I'm just going to create basically import the file system module, and then I'm going to let's create a before all where we're going to essentially load up our WebAssembly module. So let's just do that very quickly. And what we will do is do a const WASM equals fs.read file sync, and we're going to load in the Fibonacci file, WebAssembly file that we are about to create. So that is loaded there. And then the other thing I want to do is just create a buffer. So we will just do a new uint array, and we will put our WebAssembly module that we're about to create in there as well. So essentially what's happening there is, from a file system perspective, we're just going to read in the file, right? So we'll just read in the Fibonacci WASM file that we're about to create. And then what we'll do is stick that into an unsigned integer array. And that's essentially, that'll form a buffer. So that'll be there. And then what we're going to do is be able to access that module. So Fibonacci is equal to await, and then we will use the WebAssembly module, and then we'll call WebAssembly instantiate, and we will pass in the buffer that we just created, and then we can get access to the function that we've exported. So off we go, and that puts us in a pretty good space there. The last thing is, we've got Fibonacci here. I need to access that down here, this Fibonacci, Fibonacci, Fibonacci. So all I'm going to do is do a let Fibonacci over here as a global, and then we've got access to it down here. So I've got my tests, and if I was to run my tests just now, so if I just do an npm run test, you'll see all my new tests that I create Fibonacci will fail because there's no Fibonacci.wasm file that I've created. So we've got our test set up now. What we're now going to do is hand code the Fibonacci file in WebAssembly text format. Okay, so the first thing we're going to do is create our WebAssembly text format file. In my other videos, I have a real deep dive into things like WebAssembly, stack machines, how to get started with WebAssembly. I kind of recommend that you watch those videos because this is going to make a lot more sense if you watch those videos. But even if you haven't watched this, you should be able to get this as we code this as we go along. Okay, so but go watch the videos, right? Why not? But anyway, so if I just call this Fibonacci .wat, which stands for WebAssembly text format, and then what I need to do is I need to create myself a module. So how we do that in WebAssembly text format is we call it module, and modules in WebAssembly is equivalent to ES6 modules, right? So you can call JavaScript from a WebAssembly module, and likewise a WebAssembly module can call JavaScript as well. So they're very interchangeable. To do this, I need a func. So func is the keyword in WebAssembly for function, so it works exactly as any other function in any other language. And I need to give my function a name, so in this case is Fibonacci. And then I need to pass in some parameters. So the parameters that I need to pass in is going to be the index of the Fibonacci sequence. So Fibonacci of 0, 1, 2, 3, 4, 5, etc. Whatever numbers in the sequence. So I will just pass in a parameter and I will call that index for the sake of easiness. And then it needs to be have a type. So in this case, it's going to be a 32-bit integer, which in WebAssembly terms is i32. And then the next thing that I need is I need to return the result of my Fibonacci sequence. So in WebAssembly text format, that would be essentially called result. And again, it will be of a 32-bit integer, so i32. Okay, so I have my func, and let's put that there. And now what I need to do is start returning some stuff there. So we're in a nice place. We've got our function, and now what we're going to do is just essentially start translating this JS file that we created earlier, and we're going to convert that into WebAssembly text format as we go along. So the first thing we need to do is I need to set my fib of n to 0, and then I'm going to set fib n1 to 1 and fib n2 equal to 0 as well. Okay, so how do we do that in WebAssembly text format? Well, the first thing I need to do is, because WebAssembly is a stack machine, again, see my video on stack machines if you want a deeper dive into that. So what I need to do is pass 0 onto the stack. Because I can't directly assign things onto variables, I need to do everything via the stack. So the first thing I need to do, therefore, is to pass the number 0 onto the stack so that I can interact with it. So I will do i32 const 0, and that will put the number 0 onto the stack. The next thing I can then do is store whatever is in the stack, and how I do that is I pop it off the stack, and then I can put it into a local variable of my choosing. So I will do a local.set. So local.set is how I can set the value of parameters, or I can set the value of local variables in WebAssembly. So I'm going to do a local.set, and I will put that to a variable name. So in this case, it is going to be fibn. So my fibn variable is going to be set to 0. And how that works is I put 0 on the stack here. Now that 0 is on the stack, local.set will take whatever is on the stack. It will pop off that 0 from the stack, the last item on the stack, and then place that in the fibn variable. But I don't have a fibn variable as it stands. I need to declare that. Now the way that gets declared in WebAssembly is I need to put it up in the top line like I do with parameters and results. And how I do that is by going local, and then I have to give it a name. So in this case, I called it fibn, and then I need to give it a type. So in this case, it's an i32 like everything else. So there is another key piece of information about WebAssembly, right? All of my variables for functions need to be declared up top, right? So in this case, I've created a variable called fibn. I need to declare that up top there. So now I've done that. That is stored there. And again, I can put some comments in here as well. So semicolon, semicolon allows you to is the equivalent of / in JavaScript. So it's how you do comments, and then I can just say set initial values. Okay, so I've done that. And that is the equivalent of me going let fibn equal 0. So guess what? I've got to do this another 2 times now. I've got to set fibn1 and fibn2 as well. And that's pretty simple. I can just take this and I'm going to copy this. And then n1, n2, and then this is going to be 1 and this is going to be 0. So I'm doing exactly what I did before. I'm going to push 1 onto the stack, and then whatever is on the stack, which is 1, will then be set in the variable fibn1, or my fibn-1. And then here I'm going to do the exact same thing as well. I'm now going to push the number 0 onto the stack, and then I will set in the local variables fibn2 to whatever is going to pop from the top of the stack, which in this case would be 0. Finally, I need to set those variables fibn1 and fibn2, at the top here. So fib n1, fib n2, because I have to declare every variable in WebAssembly at the top. Okay, so I've got my initial values set. So we're doing pretty good so far. And then if I go back to Fibonacci JS, then the next thing I want to do is set the value of n, so my sequence, and I want to set that to index. So that's pretty simple to do. So I want to keep track of where I am in my while loop, and that's going to be n. So again, I need to do the same thing as I did before. I need to create a local called n. So I'll call that n, and that is going to be another i32. And then, because I am creating a local variable, which I'm going to use to track in my while loop, which is called n, then what I need to do is set that incoming value, that index, the Fibonacci sequence index, and I want to set that initially, that n value, to whatever value this is. So how I do that, how I access a parameter in WebAssembly text format is I do local.get, and I put in the name of the parameter, in this case index. So I'm going to get that, and what happens is whatever value I've put in there is then going to get pushed to the stack. So whatever value I call my Fibonacci, so if I want the Fibonacci of 1 or 5, then that will come through in this index, and then with local.get, it'll take that parameter index, so in this case it'd be 5 or 1, or whatever value pushed in, and now that would be at the top of the stack. So the stack would have, let's say, 5 on it. And then, because I want to set the n variable that I just declared there, then I would then do a local.set, and then I pass in the name of the variable, which is n, and then what that would do is pop off whatever values on the top of the stack, which is the parameter that I passed in, and that would be now set to n. So I now have the start of my function. So now what we're going to do is recreate that while loop, and how we create while loops or loops in general in WebAssembly text format is we need to create blocks. So we indicate that we've got a block of code, and we're going to use that for branching, and we're going to use that for looping, etc. So to represent that in WebAssembly text format, I just need to put in the word block, and that will represent my new block that I'm creating. Now, the next thing that I need in there is I need to specify a loop. That is the equivalent of a while loop. So I've now got my block and I've got my loop there. And essentially, that works like a while loop. Now, in this case, I'm doing a block loop for a while loop, but of course the same WebAssembly code would be used for for loops as well, because WebAssembly doesn't distinguish between the types of loops, right? It just knows about loops in general. How you branch within that loop determines whether it's a for loop or a while loop underneath the covers. Okay, so let's go back to our code for a second. Before I deal with this condition, the n is greater than 0, I think what I'm going to do first is just copy a couple of these bits of lines of code in here, and then we can start filling it out as we go along. So let's just take a copy of this, and then what we're going to do is we will just stick some comments in here. So we'll have the n greater than 0 comment, fib2, yep, and then we will do this. And that is going to be the equivalent in kind of pseudocode there of what we're going to do within WebAssembly text format. And then we'll just fill this out as we go along. So I'm going to skip the n is greater than 0 because we haven't learned about branch conditions yet, but we'll do that in a second. But what we do know is fib2 is equal to fib n1, right? But, that's exactly what we were doing before. So remember what I said, in order to set a variable, I need to push something onto the stack first of all. So if I want to put whatever value is equal to fib n1 and set it to fib n2, I basically need to pull fib n1, put it on the stack, and then set fib n2 to the value whatever is on the stack. So let's do that. So I would do a local.get, that's what we used before, and I'm going to get the value of fib n1. Okay, so all that is going to do is take whatever value is stored in fib_n1 just now and put it onto the top of the stack. And then in order to set fib_n2, I would just do a local dot set and do fib_n2. So I'm going to get whatever value is in fib_n1 at this point. I'm going to put it onto the stack. I'm going to push it onto the stack, and then when I do a local dot set, I'm going to pop whatever's at the top of the stack, and then I'm going to put it in the variable fib_n2. So that's how that works. And therefore, fib_n1 is equal to fib_n would work in the exact same way as well. So I could do a local dot get on fib_n, and that's going to take whatever values in fib_n at that point in time, and then it's going to push it onto the top of the stack. And therefore, if I want to set whatever is in fib_n1, then I would just do a local dot set and set the value fib_n1, and therefore that's how we would achieve those two functions. Now the next thing that I need to do is I'm going to take fib_n1 and then I'm going to add it onto fib_n2, and then I'm going to store the result in fib_n. Now if you remember one of my previous videos, the one on the stack machine, what we did is we introduced an add function, and how we did an add is we essentially pushed two values onto the stack, and then we called the add function, which added them together and then pushed the result onto the stack. Let me show you what I mean. So in this case, what I would need to do is I would do a local dot get, because I want fib_n1 to be on the stack. So we'll do that. And then I'm going to do a local dot get, and I want fib_n2. So fib_n2 would be on the stack. So I've now got two values on the stack, fib_n1 and fib_n2. And then I'm going to call i32.add. And what i32.add does is it will pop two values off the stack, which I have, fib_n1 and fib_n2. And then it's going to do the calculation, add them together, and then it's going to push the result onto the top of the stack. So fib_n1 and fib_n2 would no longer be on the stack. They got popped off when we called add. It's done the calculation, and then it's going to push the result onto the top of the stack. So that will now be on the stack. So in order to set fib_n, all I need to do is a local dot set, and I can set that value to fib_n. And we're good to go. So now the result of that calculation is going to be stored in fib_n. And then the final thing that I want to do here is basically do a decrement of my n, my index. So to do that, it's just the same as an addition. It's basically a subtraction. So what I'm going to need to do here again is I'm going to need to take n and I need to push that onto the stack. So to do that, I would do a local dot get, and I would put n there. So that gives me my local dot get. And the next thing that I need to do is because I need two items on the stack to do my subtraction, because an n minus minus is essentially, n minus 1. So it's a subtraction, subtract 1 from n. I've got n on the stack, so I need to put the number 1 on the stack. And that's pretty simple. I would do i32, which is, I've got a 32-bit integer, and I want to push the constant of 1 onto the stack. So now I've got n on the stack and I've got 1 on the stack, and therefore to do the calculation I just need to do i32.sub, which stands for subtract, and that would therefore minus 1 from n. Yep, and because it will have popped those two items off the stack, it had n and 1 on the stack, it's popped them off, it's done the calculation, and then it's going to push the result of the subtraction back onto the top of the stack. So I had two items on the stack, n and 1. Both of them got popped off, so the stack is empty. I've done the calculation, and the result of the subtraction is pushed back onto the stack. And then finally, I need to store the result on n. So all I'm going to do is a local dot set and put n there. And that means whatever result there is now going to be stored on n. So I've got my n minus minus, and we're sitting in a good space. So there's two things I need to do now. The first thing I need to do is make the thing loop, and then the second thing I need to do is go back to that condition at the beginning to check to see if the loop has completed. So to do that, so to make that thing loop, what I really need to do is send it back to the top of the block, send it back to the top of the loop. So we'll just write a comment, send our statement back to the top of the loop. And how we do that in WebAssembly language is we're going to call a branch, br, and we're going to call 0. So what it means there with a branch of 0 is it means go back to the top of the stack there. So branch of 0, the top of the call stack, that is. So that's 0, and so it's going to go all the way back up to the top of this loop and then re-execute that again. And that's how that works. So br0. It's basically a go-to. I know go-tos are evil, right? And everybody, especially Dystro, really disliked go-tos. But underneath the hood, and you shouldn't write go-tos, but underneath the hood, that is what WebAssembly is doing, right? It is essentially doing a go-to back to the top there. Okay, so we now have a loop, and that's just going to go on forever, but we need the ability to break out of that loop. So how we're going to do that is we need to do essentially the equivalent of an if statement. So we're going to check if n is greater than 0, and if it's greater than 0, then we want to break out of this loop. We want to go one level above. If we remember the statement here, what we are actually looking for is we want to keep looping while n is greater than 0. But if n becomes 0, then we want to break out of our loop, right? And remember, our loop is decrementing all the time, and it's decrementing because we're doing this n minus minus at the bottom there. So essentially what we are looking for is we're actually looking to see if n is equal to 0, because if n is equal to 0, then we want to break out the loop. If it's any other number, then we want to keep looping, i.e. we don't want to do anything different. So even though this is n is greater than 0, actually what we're doing is n equal to 0. Okay, so how we handle that is exactly the same as how we did anything else further down when we were doing additions and subtractions. So the first thing we need to do is we need to get the value of n. And how we do that is we do a local.get, and then we ask for the variable n. So in this case, local.get is going to access the variable n, and it's going to push the value of n onto the stack so that we can do operations. The next thing we need is we need to check if n is equal to 0. How we do that is we also need to push the value 0 onto the stack as well in order to do a comparison. Well, that's pretty simple. We do an i32 const as we did before, and we put in the number 0. So that will now push the number 0 onto the stack. So we will have two items on our stack. We'll have whatever value is of n and whatever the value of 0 is, which is 0. Now that we've got two items on the stack, we're going to do a comparison function. We're going to check to see if the two values are equal to each other. And how we do that is we do an i32.eq, or equal. So what that does is it will pop two items off the stack, which in this case is n and 0. So we'll pop them off the stack, so the stack will be empty. It will check if they're equal to each other, and then it's going to push the result back onto the stack. That's how it works. It works in the same way as an add or a subtract, right? So if they are equal to each other, then the value on the stack will be 1, and if they're not equal to each other, the value on the stack will be 0. Fine. So we now have on our stack the result of that operation. So how do we then break out of our loop if they're equal? Well, like down here where we did a branch of 0, which basically sent ourselves back up to the top of the loop. So the way branching works is it looks at blocks and then it keeps a count of the number of blocks that you have. So over here, this is really block 0 and this is kind of block 1, right? So it's following an index. So in here, when we did a branch 0, it's basically saying go back to the top of the current block, right? The call stack that you were within. So this is basically how call stacks and loops work in regular world. So all this is going to do is it's going to just keep going round and round. So what we need to do is we need to break out of this block. We need to go one higher. So we are going to be looking at the index. So we need to go one index above. So essentially to break out of this, we would need to do a BR1. And that would break us out of this loop and then bring us back up to here, or rather down here. And that would allow us to continue on. Now, in our case, we don't want it to just break at this point. We only want it to break if those two values were equal. And how we do that is we do a BRIF. And how a BRIF works is it's just going to check the top of the stack. So it's going to pop whatever item is on the stack and it's going to check if it's true. And if it's true, it's going to do that. And if it's not true, it's going to continue on. And that is how we break out of our loop. Okay, so we're doing pretty good. We only need to do one more thing. One more thing. We just need to return the Fibonacci now. So to do that, we just need to see where we are in the block. So here's our block. You can see it ends here. And to return a value from a function, what I need to do is put whatever value I want to return as the top item of the stack. So that's pretty simple. All I need to do in this case is do a local.get, and I'm gonna grab Fibonacci of n. So fib n is where I was storing the Fibonacci value, and then I'm gonna get that value from that variable, and then I'm gonna push that onto the top of the stack, so it's sitting there waiting, and therefore that's what's ready to be returned. So whatever's at the top of the stack will be returned in this result. And then finally, the last thing I need to do is do an export. So I will just do an export, and I'm going to call my function Fibonacci, and it is of func, and the name is going to be Fibonacci also. So we're going to save that. That is our hand coding over file, and we're going to come back to the terminal and we're going to see if this works. Yep, so the first thing I need to do is compile it, and once I've compiled it, I'm going to run my tests. Okay, so let's come back to my terminal, and I'm going to compile my Fibonacci.wat to WASM. So to do that, I need to use my wat to WASM compiler, which is part of the WebAssembly binary toolkit. I'm going to put in the name of my WebAssembly text format file, so Fibonacci.wat, and then I'm going to output it as Fibonacci .wasm, and then if I'm lucky it works, and if I'm unlucky it doesn't work there. So in this case it doesn't work, so let's have a look at my code and see where I got it wrong. Okay, so let's have a look at where we got wrong. So if we look at the errors, it says undefined local variable fibn2. Okay, so let's have a look. So I've got my local fibn, and then I've got fibn1. Ah, look, I've called it fibn1 twice. So I'll just change that to fibn2. Come back to this and then run my compile again, and it worked. So I now have my Fibonacci.wasm file, so we're looking good. And if I just do an ls, you can see my Fibonacci.wasm there. And now, for the moment of truth, we're going to run npm run test. If we're lucky, it works. If we're unlucky, we're going to be doing some more debugging. Let's see what happens. And we're unlucky. So let's have a look at where I got this wrong. So I think we're actually okay, right? If we look at that, it's saying instantiate is not a function. So I think, in all honesty, I think I've just misspelled instantiate. So if I come here and we put instantiate there, we hit save, and then we run my tests again, I think we'll get lucky. And our test passed. Okay, so we now have a Fibonacci function that works in JavaScript and in WebAssembly. Anyway, I hope this video has been useful. Hopefully you can kind of see how looping works, how branching works, how the use of go-to statements works, how you do comparison, and it's giving you a bit of a deep dive technique on how you can compare between JavaScript and WebAssembly. Now, the good news is, why are you doing this? Yeah. Now, you're probably wondering yourself, oh my goodness, hand coding WebAssembly is a complete pain, and it is. But you will never do that in reality. You're always going to use something like Rust or Go or AssemblyScript, etc., or C or C++ to go and create these WebAssembly files. But actually, by understanding how to hand code WebAssembly text format and create WebAssembly modules by hand, that's going to make you a better programmer, because when you go and use the higher level languages, at least you're going to have a better idea of what the WebAssembly is creating underneath is doing, and it'll help you optimize and write better code. Anyway, I hope this has been useful for you, and we'll speak soon in another video. Thanks very much. Bye.